Okay, and so I'm back. In this video, I'm going to take the output from Java programs using the WEKA classifiers to make 30-day trend estimates, and using that ensemble of output average out a predictable 30-day trend. Now, this is not like the WEKA ensemble functions, similar to bagging and voting and things like that, but similar. For more information about that, check out the video by Professor Ian Witten, available at Future Learn, and there is the URL for that. What we're going to do is pretty much like they're called spaghetti maps from hurricane weather predictions. For instance, this one from Dorian from a couple of weeks ago. Bunch of different models, and then the weather forecasters will use an average of those forecasts. The training and estimating of the data using the WEKA functions we're going to take a hybrid approach, just like I did in the weighted average expected value estimator I presented in the last video. The training functions during training, we'll use a classification of a buy or a sell, going through a whole bunch of different, selecting the best parameters, using it with the random forest classifier. And then during the evaluation phase, we'll take that percent correct for each of the runs, and we'll use that, the best percentage, we use the best percent correct, the highest one, and store the results of the best parameters in a CSV file. And on the other side, while we're doing estimates, we're going to do a regression where we, instead of using a buy or sell class value, we're going to use a percentage change for each of the 30 days that we're going to be estimating against. There's one auxiliary class that the package will use. It's called the abstract best parameter, and all the classifier programs use this as a convenience routine. It just collects the parameters that are used to generate the R file to build for the random forest classifier. There is one abstract class, actually it's almost a main class, the WEKA classifier ensemble functions. There are certain, it contains functional methods that are shared by the classes that will do the actual R file building. The abstracted methods that will be in those subclasses are building the ARF header, and then actually, get what I can see, actually does build the data attribute values. Inside of the WEKA classifier ensemble functions, these functional methods are accuracy tests, which will build data for the calls to the WEKA classifier, calls the subclasses to build the R files, and then it will run the evaluation class. It also has a method in it called getAllAverages that will output the 30-day trend data. The subclasses based on the WEKA classifier ensemble functions that I present here are double moving average, one that uses a MACD and an RSI, one that uses a momentum and the average true range, and another one that uses the stochastic momentum indicator. I just put these together on the fly. Feel free to change them, come up with new ones. Each of these classes contain a static main method that builds the CSV file. In main, there is a loop for 1 to 30 days that calls the best parameter method, which will iterate all over the possible values of usually a period, but it could be other possible values, which in turn builds the R file for each one of those iterations. The R file gets evaluated again to a classification of a buy or sell, and the parameter set is the parameter set that with the best or highest percentage correct value from the evaluation phase is then returned to main, and those parameters are stored in the CSV file. And the last step in the whole process is to generate the 30-day trend data with the average of all class. Average of all class calls each of the subclasses to return the estimated percentage change for each of the 30 days based on the current period. Then it will, average of all, will take the estimated percentage change and multiply that by the current price to produce a future price value or trend. The classes that build the R file are based on the best parameters, again from the original phase, for each of the 30 days, and it makes, again, a regression estimate of the percentage change. So it doesn't pass a buy or sell to the class attribute, but it passes the percentage change value for that particular day. Again, so we're going to have more than just a one period prediction. For instance, on a one-day look ahead, for instance, today's data, if there was data produced for today, with a one-day look ahead, we'll be able to produce data, an estimate for the next day, for tomorrow. And for a two-day look ahead, we'll be able to use today's data, predict data for 2 days out, the day after tomorrow, and we'll be able to use yesterday's data to predict, give us a prediction for tomorrow. And then likewise on the third day, we will be able to do the same thing. Today we'll be able to produce data for 3 days out. Yesterday we'll be able to produce an estimate for 2 days out, and 2 days ago we'll be able to give us an estimate for tomorrow. So we'll be able to take all of those estimates for say tomorrow's estimate, and we'll take we'll average out the value of predicted value for that, and that would be for 1 day. And then there's an instance of it predicting it for 2 days, and we'll be able to go out all 30 days. One of the things I'm a little concerned about is if we use data from the data from 30 days ago and make an estimate, and to give us it'll only be able to give us an estimate for tomorrow using the 30-day predictor if it's from 30 days ago. Then is that data really that valid from that period? That's a decision you'll have to make, and I do provide a parameter in the average of all class to let you stop going back so many days, and we'll see that when we take a look at the code. Before we begin, if you like what you see, hit the like button, share it, and subscribe. First up is the auxiliary class abstract best parameter. This class is used as an inner class by the programs that call the ta-lib functions and build the WEKA R files. The parameters are specific to those ta-lib functions that these programs use. As it collects this data, you'll see in the examples that for each day, when it finds the best results from the evaluation phase, it will store these parameters in a CSV file. And when it comes time to do the estimates, the CSV file is used again. It's read in, the parameters are parsed out and passed to the correct ta-lib functions, and then the R file for the actual estimates are built. Next up is the abstract class that all the Java classes that build the classifiers based on the ta-lib output use and extend this class. It contains several interesting fields. First off, stop testing here is used to indicate the number of days worth of data that is included in the test R file. All the remaining data is included in the training file. Use this classifier. It just ensures that all of the subclasses use the same WEKA classifier. A couple of abstractions are get arf header, because those are dependent on the subclasses, and that goes along with the get attribute values. A functional method included here is the accuracy test, which goes through, it's called by the subclasses, It does the exact same thing. It builds the two R files, the training file and the test file. Along with the class attribute. And during the training test phase, we do a classification based on a sell or a buy. As we see in the estimate phase, we will do a regression of the actual percentage change for the current date as against the date in the future. The instances are built, a training instance along with the test instance, and then the evaluation is done, returning a % correct value for that specific set of parameters used. And the programs will use this accuracy percentage to determine the best set of parameters. I use % correct. Others will probably use area under the curve and things like that. And then the last functional method in here is get all averages. This is used in the output phase, or when we generate the estimates. It's pretty similar to the get all averages, but in this case it's only going to do it once for each day that's passed to it. As we can see, the value days diff has been defined earlier, but in this case, again, we're doing a regression based on the percentage change between the current date and the days in the future. Again, the values are instantiated in a training file, and in this case, the test file will have the class value of a question mark, so that it will give us a percentage change estimate. This percentage change based on the day's difference, because we can have more than one, is stored and averaged and is returned to the another program that we'll see called average of all. So here we have an example file that we'll call ta-lib and WEKA to build classifications. It's called double moving average. It goes through two sets of moving average periods, and it will call, as you see here, the ta-lib provides several different types of moving average types, so it will actually try to find it'll include a parameter for the best moving average type. This here is that inner class I was telling you about that implements or extends the abstract best parameter, where it stores the parameters you use for this specific class. The results from the ta-lib are stored in a class fields. In this case, we have a fast moving average and slow moving average numbers, and the current move average type that would be being used. This field here is used for the CSV file. All the programs share the same logic in this main. As we will see, in main's function here is just to build and find the best parameters and store them in the CSV file. One of the things that I do in this code is I actually read the CSV file, see where I stopped the program running, because some of these applications or some of these classes, when they run, can take more than a day. So I'll stop them to do something else on my machine, and when I restart, it will read through the CSV file, find out where was the last day it stopped at, and then it will pick up from that point. And then we actually call the best parameters, which is a static method below, where we pass in the stock prices that were read for that particular symbol and the number of days what we're looking ahead for. The best parameters, again, it's going through, and it's going to go through to build all the possible parameters that we want to test for. In this case, the moving average types, the fast and the slow period. The parameters are stored in a string array and then passed to the best parameters class. We set the limit here for the break between the training and test ARF files. and then we'll actually call the function or the class that is being tested, in this case, obviously, a double moving average. Double moving average will have a class, has that class in the that main abstract class called accuracy test, if you remember, and that will return the accuracy value. In this case, I call it expected value. Don't ask me why. Probably some leftover code. And based on what was returned, if it's greater than what we recorded before, then we're going to store the best parameters and update the best value. And then it will return the best parameters to the main function, or the main method that we saw up above, and then main will write those back out to the CSV file. The class here is passed the best parameters. This is the instantiation of the class. We build the ta-lib, in this case a fast moving average, based on the fast moving average period we pass to it, and the ta-lib moving average type or function that we want to call. And we do the same thing for the slow. I just want to reiterate this, that you always want to do a realign. If you don't do a realign, your numbers will not be correct, and they will look better than they really can be. One of the abstract classes also in that other, in the main class is there's two abstractions in the main class. These are the overrides. So one of them is to build R files that are dependent on the function. In this case, the double moving averages. These are the attributes that are used, pretty much pretty standard. I just kind of threw these out and tried them out. The R file has one simple test. If we're doing a classification run, we're going to do either a sell or a buy for the class index. If you remember, during the training phase, we do a classification, and in the actual estimations phase, we do a regression. So during the regression phase, we specify the class index attribute as numeric. And then below at the back, over in that other main class, it was calling a get attribute values, and this is where the attributes are loaded into the that will be loaded into the R file. They're appended into a string buffer field, and then the string buffer field returns as a string, and each string is returned is written to the R file that is being used. And finally, the output phase, and this is the phase, this is after the attributes have all been found, for the best attributes found, and now we're going to actually do an estimate. And this function, or this method, is called by average of all. Average of all will go through each of the classes that it knows about and calls this, and then it passes in an averaging field based on the number of days. This integer key is the number of days. It will read in that CSV file that we built before, reparse the parameters, build a best parameters function, and then we call the class again. And this time it knows that it's doing a regression. That'll be done. And then get all averages is back in the main class. Let me just jump back to that. Again, it's going to build a training and a test file, but the training file will have in it the regression values of the number of days forward divided by the current day's close. That will give us a percentage change, and then the test file will have in the question mark for so that the classifier evaluation phase will generate an estimate for us. Quickly, this is what the double MA best parameters files look like. And again, there's the number of, that's the number of days look ahead. This is the fast parameter, this is the slow parameter, and then this is the name of the ta-lib library that is called. Okay, now we can go over to the average of all, which is actually going to be the output phase of the program. An average of all will call each of the, it's going to build a tree map of averages based on and with the key being the number of days look ahead. It's going to call the static method in each of those subclasses to build the R files and give us an estimate. Then it has a little routine inside of here locally and get all averages to print them out to the console. I will take that console output, and we can. It's going to be a CSV file format, and we'll just drop that into a spreadsheet, and it'll give us a chart. But what I've done here is I included a program to called XY Chart Builder that's available at let's see, at go to www.knowm.org, and you'll be able to get the chart builder function. Print averages goes through all of the different days, and it averages out, taking the average gotten from the subclasses, which is a percentage change, but we will apply the current closing price for that symbol, and that'll generate some output that we can see, and we will see that when I run it here. I run all averages, and this is based on data collected as of September 13th, 2019. Today the stock market was down. Energy stocks were up. Precious metals were up. So again, here is an instance where there's been a black swan event with the attack, and so we're doing an estimate of 30 days out, but because of that black swan event, those estimates really shouldn't be all that correct. They should be more in line with if something didn't happen. Each class kicks out 1 to 30 days worth of estimates. You can take this output, and there's 2 more programs we're waiting for to run. Take that output and load that into paste that into a spreadsheet, and then from the spreadsheet we can generate a chart. But in this case, we're going to be using that XY chart program from knowm.org. All right, this last one should be pretty quick. As you can see, that today's estimate is for a 302. Yeah, here we are, all done here. So today's estimate for for SPY is 303.17. But if I look over here, today's close, again, because the oil refinery problems are in Saudi Arabia, SPY closed at 300.21. So again, the event has messed up the averages. Then here's the output that you would get the same thing if you charted this with a spreadsheet. The dark red line is the average of all of the other functions output, and as you can see, if we look out 30 days out, which should be probably the first week of November, we're expecting the SPY value to drop consistently. And then again, these are not estimated prices. I don't look at these as estimated prices. I look at these as a trend, and the trend to me is looks like it's going to be down out in 30 days. Okay, that's it. Remember, if you like what you see, press the like button, share it, and subscribe. Thank you.